Hello everyone, this is the video lecture for pre-calculus. We're going to be doing 5.7, inverse trig functions. So first off, what are they? There's something you've actually seen before in our previous videos, but let's just re-talk about it, I guess. Normally we have sine of theta is equal to some kind of number, some kind of ratio. Like for example, 1/2, square root 3 over 2, I shouldn't put an equals there, but you get the point. So it's some kind of ratio, some kind of number, unit circle, that kind of thing, okay? But now, okay, hold on, one last thing. And this is an angle. That theta is an angle. Now I'm saying theta is equal to the arc sine of some kind of ratio, some kind of number. And it depends on what it is, of course. So I said that was arc sine. I guess you could also say sine inverse, and I understand that. That's totally fine. That's not a bad name. Sine -1 is, well, I understand it. It's not a proper name, but I understand it. But I often just say arc sine. That's just my way of saying it. You could also write this as, say, arc sine, something like this. And again, that's going to be some kind of ratio, and whatever that is. So arc sine, and both of these actually work in Desmos Scientific. So you can type it out like that, or you can do a little -1 power, and everything's fine, okay? The main thing is that these are equal to angles. We're trying to find an angle from a ratio. And so here's a good example. I'm using sine here a lot, but let's say I'm looking for the arc sine of 1/2. I'm saying look at the unit circle, and you're trying to find when the y value is 1/2, and then what's my angle, like in degrees, that kind of thing. So I'm looking around, and my y value, here, unit circle. That's the ugliest unit circle I've ever drawn. Bam. The unit oval. Anyways, so here, 30 degrees. Yes. So I got the square root 3 over 2, positive 1/2. I'm looking for the y value being 1/2. Yep, check mark, 30 degrees. There you go, we're done. So that's not too bad. Let's do another one over here since I got room. Let's do arc cosine of square root 2 over 2. I'm looking for an angle where you see the x value, right? This cosine is x value. And like this is actually the x value itself on the unit circle. It's right here at 45 degrees. Again, let me remind you, square root 2 over 2, square root 2 over 2. I'm just looking around trying to find that guy in the x value. What's the angle is 45 degrees. So it's backwards from what we've been doing, but at the same time, it's really pretty simple stuff, honestly, okay? Now, it gets more complicated when it's not on a unit circle, but then again, you use a calculator and you're done, honestly. I think I'm saying honestly a lot, honestly. So, I have my notes here, and then it says that I skipped a lot of multiple choice in the beginning. And again, I'm not worried about it. You should not be worried about it. Click, get it right, get it wrong, get it right again. Moving on. So here's the first problem that we're doing is arc sine of square root 3 over 2. And they want both degrees and radians. Okay, so we just did this. I mean, this is easy stuff. I'm looking for the y value equal to square root 3 over 2, and I see it at the 60 degrees. 1/2 square root 3 over 2. There's my y value, right? Sine is a y value, and I'm looking for the angle. The angle is 60 degrees. What's the radians? It's right there on the unit circle. It's pi over 3. And you're done. That's the end of the problem. Nothing else to do. Let's do another one. And so I got 5, 7, 9. Arc cosine, make that a little bit better, of negative square root 2 over 2 is equal to what? Again, degrees and in radians. Now, this one's a tiny bit different. Notice that we have a negative. And I've been doing an assumption here with you for a while now, but I'll show you what I mean as we keep cruising here, okay? So I'm looking for a negative square root 2 over 2, and I see it right here at 135. I have, again, negative square root 2 over 2, positive square root 2 over 2. So there you go. There's your answer, 135. That's also 3 pi over 4 on the unit circle. Done. And yes, you are done. That's it. There's nothing else to this problem. But is there another one? Yes, there is right here. This is at 225. We have this square root 2 over 2, this negative square root 2 over 2, and then another negative square root 2 over 2. Again, I don't really care what the y value says. I'm looking for the x value. And indeed, I do have that right there. So I feel like I also need to chime in and say, hey, it's also 225, isn't it? MyMathLab does not want that. And it doesn't want a comma, like you're thinking, we'll just put a comma in there. They don't want that. Why? X. No, I'm just joking. So, yeah, but why? Why is it that they don't want these extra answers? And, going back to this one even, is there another one? And yes, there is here at 120. 120. We have the same thing. This is a negative 1/2. Positive square root 3 over 2. There you go. So 120. Isn't that also going to be part of the answer? No. Why? And I'm going to tell you, and this is a rough answer why. It's because the calculator tells you. I'm serious. If you go and put this into the calculator, Desmos Scientific, and you put this guy in, guess what you're going to get is 60 degrees. And that's it. You're done. Do what the calculator says. I'm serious. Same thing here. You'll get to 135. You're done. That's it. Let the calculator give you the answer. I'm serious. Now, why are we thinking this way? So, I got to tell you, there's a little thing here, okay? So, you know how we talk about domains sometimes? Well, this is called the range. Again, this is the y values, the answers out of this. The range for arc sine, I'm just going to do arc sine just as it is there, is negative pi over 2 to pi over 2. I'll explain all this here in just a second. I think that this is okay to write down, but I wouldn't set this thing in stone in your brain. It's not like it's going to make or break you in the class here, okay? Its importance is moderate, but not significant. So there's your honest answer here. So the range of arc sine is between negative 90 degrees and positive 90 degrees. The range for arc cosine is 0 degrees all the way to 180 degrees. And tangent is the negative 90 and 90 again. What I'm saying is that you have got to get an answer somewhere within this zone. And that's it. That's the only answer you ever give. And so with my cosine, did I have an answer that was between 0 and my 180? And I would say yes. But what about that 225? Is that somewhere between 0 and 180? No. Again, I would rely on the calculator to tell you, just because it's super easy. It gives you the answer every time. Moving on. So the calculator is kind of helpful here. Again, so the bigger question, why do they do this? It's just because it's math, and you got to do something. So that's what they made up. They made this up, and they said, that's what we're going to do. I'm sure that there's a lot more behind it, but that is not needed in this particular class, okay? If you want to do theory on this later, that's fine. Not today. So arc tangent of this thing. Arc tangent's always a little different than the others because we don't have tangent values on the unit circle. At least I don't. I probably should write them down sometime because, they're helpful. What I'm going to do here is I skipped ahead about 5 steps. So let's talk about the 5 steps that I just did. I need to convert this over into something that's more feasible. So first off, I want to do a divide by 2 for both of them. I want to create a divide by 2 for both of them so that I get something that's recognizable. Aha! I seen square root 3 over 2 before, but its partner is not 3/2. Its partner is 1/2. So actually, this is not a good step, but it's close, okay? What I actually want to do first is unrationalize the numerator. I'm basically going backwards on the rationalization step. So what's happening here is that I'm multiplying it by the square root of 3 over the square root of 3, which is legal, right? And then in the top, we get a plain 3, and then I got a 3 square root of 3, and the 3's cancel, leaving a 1 over square root 3. And then I take both the top and the bottom and divide them both by 2. Again, I'm just making this stuff out of nothing. It's math magic, man. And so then I can put that in here. But the reason I did that is because my tangent is supposed to be y over x. And so I have a y value and I have an x value. So where is that angle on the unit circle? So let's go and try to find it. I'm looking for this particular point on my unit circle. And I'll tell you, it's right over here at 30 degrees. Let's verify. I have the square root of 3 over 2, comma 1/2. Did I get an x value with square root 3 over 2? Yes. Did I get a y value of 1/2? Yes. And so 30 degrees, that's my answer. And they want the radians also, so that's going to be the pi over 6. And that's it. Wow. Or you could have just plugged it in a calculator. So, next question. We got 5, 7, 21. I know. All right, so I know some of y'all might be saying now at this point, well, arc cotangent, you can't put that into the calculator. You can if you flip it. Now, remember that cotangent and tangent is like 1 over it. But it's the ratio that changes, not actually these tangent cotangent thing. What's happening is that I flip the inside. Yeah, isn't that an odd one? So I take this one, it was actually divided by 1, and I'm flipping this on the inside to get to an arctangent. Use the calculator, and you're done. And I'm going to be straight up here with you. The calculator is very important here, okay? So I put this thing in. And again, you could do it the long way. Fine. I'll show you the long way. And so I'm looking for that point somewhere. I have a y is the 1/2, and the x is the square root 3 over 2. It's not here at 30 because there's a negative, okay? What's actually happening is it's over here at, say, like 150. And so that's one answer. We can also say that it's down here at negative 30, I guess. That's also legitimate. And so your tangent, if you go to the calculator, its range is negative 90 to 90. So you're going to get a negative 30 out of this guy, okay? The problem is that it's wrong. They wanted 150 degrees. Yeah, or again, 5 pi over 6. So let's pause for a second here on this, right? You got this from the calculator, and it seemed fine. And I even mentioned the other guy that was around. The reason why is because I got a negative here, or I could have a negative down here. Notice, I can have a negative 1/2 over a positive square root 3 over 2, or I can have a positive 1/2 and a negative square root 3 over 2. So either way, it's still legit. So which one is it? And that's the thing, I don't know. I chose this, didn't like it. It wanted this one, so why? Here's another tiny little thing here for you. The range of cotangent just so happens to be, arc cotangent, just so happens to be 0 to pi, okay? Now, where is that coming from? I thought tangent was from negative pi over 2 to pi over 2 kind of thing. Well, let me just draw for you tangent and cotangent beside each other. This was the tangent. If you remember, we've already done this before. Where are these markers? Pi over 2, pi over 2. But cotangent graph looks kind of like this here. And this is at pi, this is at 0, and this is closer to the cotangent. So this is tangent, this is cotangent. Notice that my domain for cotangent is from 0 to pi, okay? So the range for the arc cotangent is from 0 to pi. See that? 0 to pi, 0 to pi. It's weird. This is domain, and now it turned into range. Why? Because it's inverses, and you switch your x and y. Whew, so much theory. You don't need any of that. Just try the negative 30. If it doesn't work, try the other one. And I know it's not a perfect solution. I know that. But I would so recommend using a calculator to at least guide and assist you. And you're going to get some wrong. I get them wrong too. It happens. But in the end, it's better just to kind of figure out the system and kind of just go with the flow. I know some of y'all are just not liking that. I'm sorry. I'm your math teacher, and I'm just saying go with the flow. I know. It's tough. Tough life. So I ain't got a better answer. So my cosecant, I want to now say it's a, it's an arc cosecant. Turns into an arc sine. And again, I'm flipping the inside. Now, be careful. I want to make this look pretty. And so this is technically a square root 2 over 2, if you've done a little bit of math there. Negative, so negative y values are down here at, again, negative 45, or you can say 315, whatever makes you happy there. Another one, another one's over here at the 225 mark. Yeah, that's fine. So what's the answer? It's negative 45. That's right. Negative 45 degrees is the right answer, because that is between here, let me write the other radian answer. Because that's between negative 90 and positive 90. Okay? So how is it that the cosecant is okay to keep the same range as the arc sine, right? So why are they the same? It's because... Next question. So... No. I'm not. It's not silly math. I'm truly saying just use a calculator, and like 99% of the time, it's gonna be okay. Like, here's a perfect example. They even say blah blah blah. Use a calculator. Like, here, is that anywhere on your unit circle? No. Just make sure you're in radian mode for this particular question, because they want the radians. Oops, radian. Radian mode. Make sure you stay in radian mode. You're not going to try to give them degrees or something weird. Type that in the calculator just as you see it. 1.32076. They're even saying calculator good. I'm serious. Next one. 5/742. So this is a funny one here. Arc cosine of the cosine of 6 pi over 7. If you type that in to the calculator, you're actually going to get a weird decimal that they don't want, okay? Now, the answer is going to still be in radians, because they have this arc cosine is going to be an angle in the end. But do you see the trick to this? I'll wait. Yep, you cancel your cosines. Bam! I mean, it's just like whenever you're saying like f inverse of f of x, and this goes way back into the algebra side of things. You cancel everything, you got x, and you remember these silly little problems. At the very end, you had to say, verified. Yeah, okay. So that's the same thing here. You cancel and you get it. Now, not every single time does the canceling make it so clean, okay? But it really does. It works a lot of the time. Okay, 5/763. I've got the cosine of the arc sine of 7 over 25. Okay, now let's pause for a second here. This is a little different, because what you're actually going to get is a ratio. This is a number. It's not a radian. It's not a degree, okay? Could you just put this into the calculator and get an answer? Yep, you're right. 24 over 25. That's your answer. You're done. I'm serious. But let's learn a little bit about this. Because going forward in this class, going forward in calculus, this particular kind of question actually will come up. Okay? So in this class, we're going to have these identities eventually, where you'll see this come up, and then in calculus you'll have moments like this. Not every day, of course, but what do we do? What do we actually want to do when we solve it by hand? Is we want to see this here as a theta angle. Okay, So what we're actually looking for in the end is cosine of theta is equal to something. Okay? Now, what is that angle? I don't know. But let's go and find out on the side. I'm going to draw a triangle, okay? And that's not the best triangle, but, you know, it works. Sine says that this right here is a y value, and that is my r value. So my y value is a 7. My r, or my hypotenuse, is a 25. And so then how do we find the adjacent? And I'm just going to put a theta here. How do we find it? Pythagorean theorem. 25 squared, 7 squared, blah, blah, blah. It's 24, okay? So this is one of those special triangles. So 24. Looking at this triangle, I'm looking at this triangle, and I'm wondering, hey, what's the cosine of this? Well, the cosine is adjacent over hypotenuse. It's x over r. X over r. 24 over 25. And you're done. That's it. Now, I even put in my notes, it says use a calculator. A calculator will help. The next one, I got a calculator. I even didn't do it by hand on purpose because you just use the calculator. But I think that some of these we should slow down on just to kind of pause for a minute and do, because you will be seeing this again later. Or you can just skip over them and you'll do them later. And I'll just reteach you then as well. And that is okay. So whenever I was doing these notes, and it's been a little bit, I did not do this problem at all. I just said, you know what? I'm tired of doing this. Let's just go to the calculator. And I was done instantly. Okay. So that was from the calculator. I have a little note here. It says, do it by hand if you want, ... And, you know, I do want to do it by hand. I want to practice just a tiny bit more on these particular ones, okay? Now, again, if they just cancel, like this guy here, that's pretty obvious. But sometimes they're a little bit more in-depth, and they're not going to give you a number. They're going to give you letters. They're going to give you X's and stuff, and you need to kind of figure that out. Okay, so here we go. I'm going to draw a triangle for that sine on the inside, okay? Now, I have a negative 4 over 5. And see how that doesn't make sense? That doesn't look right, yeah? And so instead, I'm saying that's a negative for my y value, right? So I got a negative 4 and a 5. The hypotenuse is always a positive. So I'm wondering now, what is my answer for the tangent? Like, well, first off, I need this adjacent side here. 3, 4, 5 triangle. And, yeah, we get a 3, of course. And so I got opposite over adjacent here. So I'm going to do that. So tangent is equal to opposite over adjacent. And so then I got negative 4 over 3, and we're done. Now, I have one tiny little question here. Could I have put this over here? So I had a negative 4 and a 5 and then a negative 3. Wouldn't I have then yielded my answer would be of positive 4/3, 2 negatives cancel kind of thing? Yes, that is a possibility. But remember that the arc sine here must be between negative 90 to 90. So that means it's only right here in these two quadrants. This is totally excluded. It had to be up here in quadrant 1 or in quadrant 4. Those are the only times that I could have had this theta. I know, there's so many particulars. And you can't remember them all, can you? And so just use a calculator. Okay, there's my little thing. Now, 5, 7, 83. Can't use a calculator. No. I'm serious. This time is the first time that my math lab says, nah, you can't use a calculator this time. So that's an 8x. Oh, I made it so ugly looking. Oh, it's going to be close enough. Okay, can't use a calculator. Why? Because you got an x in there. So everything that we have been doing was actually important. It was actually training us for this moment. This is a theta, and it's a positive, I guess. I don't know. I don't see any negatives, so I'll just do this here. Cosine's kind of interesting because this is supposed to be an adjacent over my hypotenuse. So this is 8x, and this is a 1, I guess? I don't know. And I'm trying to find out what my y value is, okay? So to do that, I need the Pythagorean theorem. 1 squared minus, let's fix that. 1 squared minus the 8x all squared. And so then I got 1 minus the 64x squared. And that is the best answer I got for you. I know, you can't really simplify that at all. Tangent is equal to opposite over adjacent. I have both of those now. 1 over the square root blah, blah, blah. And then divided by the 8x. There's actually no way to simplify this, so you just leave it as it is and you're done. Whew, good thing I was training myself. Let's do another one. I'm not being impatient here, at least yet. I'm just wanting to show, like, it's good to practice. It really is. And actually, I find some of these pretty interesting because I don't even know what I'm supposed to do. I just kind of wing it. Okay. And that's always fun, isn't it? When you're just kind of winging it. Oh, come on, guys. You know it's fun. You just don't want to admit it. I'm just joking. I'm just joking. Some of y'all are like, so I have a theta. And I need to find out what my angle is going to be here. So let's draw a triangle, I guess. And I'm doing quadrant 1 because, again, I don't see any positive or any negatives. I don't see any reason to put it anywhere else. Try to keep it as easy as possible. So there's my theta. This is supposed to be my opposite, and that's supposed to be my hypotenuse. Now, the thing is that my hypotenuse is a Pythagorean theorem that's already done. They've already done the Pythagorean theorem. So notice the x is right there, is x squared. So what would this guy be? That's a blank squared. That's my adjacent squared. 121. What is that? It's 11 squared. Yeah, exactly. Now, this could technically be negative, but I don't, like, it would be over here maybe, but I don't see that happening. Like, my sign in particular is positive, so it's got to be here, I guess. I don't know. I'm going to leave it the way it is. Try to keep it as simple as possible until something happens. So they were looking for the secant. And, forgot the little c there. The secant, which, if you remember, is the hypotenuse over the adjacent. I always have to think about cosine instead. So the hypotenuse over the adjacent. That is your answer. You're done. Oh, that's done. We're done with the section. Oh, well, that's nice. Okay, well, that's all I got. Thank you very much. Have a great day.